Okay, example 1. A sphere is connected to a string with a negligible mass and set in a simple harmonic motion by displacing it a small angle and releasing it from rest. So this is at rest, which means there's no kinetic energy, and this is where it's going to be released from. So U here will equal E total. When the sphere is released, it is at a height 2 meters above its lowest position, meaning that this here is going to be where potential energy is equal to 0. It can't go any lower than that. Shortly after the release, the kinetic energy is equal to the gravitational potential energy. Now, at first, I thought it meant that all of the potential energy became kinetic, but it's saying that they are equal values now. So it's going to be at that halfway mark, where half of it is potential, half of it is kinetic. If the total is the initial potential energy, then half and half would be 1/2 of the initial potential, and the other half would be kinetic energy. So we're just going to go ahead and plug in our numbers. Because it asks us for V. So to do this, I am going to subtract 1/2 mgh0 on both sides. 1 minus 1/2 is 1/2 mgh0 is equal to 1/2 mv squared. Our m's will cancel, our 1/2s will cancel, and we're left with v squared equals gh0, which means that v is equal to square root of gh0, which does not give us, I was saying if you, the reason why this is underlined is because in another video I tried to make, I was just saying that if you were to make the mistake of putting it all the way down, that would be the answer. But instead, when we do it correctly, the answer is 0.45. All right. Moving on to situation number 2, we have a block is attached to a horizontal spring is initially at rest at the equilibrium position x equals 0. The block is moved to position -A, as shown in the figure, and was released from rest, undergoing simple harmonic motion. At the instant the block reaches +A, another identical block is dropped on and sticks to the block in figure 3. As in figure 3, like a 2-block spring system then continues to undergo simple harmonic motion. Which of the following correctly compares the total mechanical energy of the spring before the collision to the E total 2 to E total 1? Well, E total 1 is, again, given by 1/2 Ka squared. So we're going to have -A, but it's just going to be positive by the squared. So we have that. Now, even though another block is dropped on, that would be E total 1. E total 2 is still get brought back to a +A squared. So we're just going to go ahead and have the exact same number. All right. Example 3. A block 1 of mass m and block 2 of mass 2m are attached to identical springs. Both blocks are displaced the same distance from the equilibrium and released from rest, undergoing simple harmonic motion. Block 1 has maximum kinetic energy, K1 max, and maximum speed, V1 max. Block 2 has maximum kinetic energy at K2 max and maximum speed at V2 max. Which of the following correctly compares? So there's two things we're comparing. It's K and V's. So, but here it's saying that it's K1 max. Wherever we have a maximum K, we have the total energy would be K, because the maximum kinetic energy, the potential energy has to be 0. So K1 max. So because that's true, and E total is equal to 1/2 Ka squared equals K1 max, then what we find is that it doesn't matter what the mass of the block are, the K's will equal each other. So it's either A or B. However, just because the K's equal each other, K itself does depend on mass, because it's 1/2 mv squared. So the speed will depend on how much mass there is. So for K1, we have V1 is equal to the square root of 2K over m. And for V2, because it's 2 times the mass, we have square root of 2K over 2m. And that means that the denominator is higher here, so the velocity is lower. So V1 max is greater. All right. Example number 4. The mass of The block is 0.25 kilograms. The spring constant is 100 newtons per meter. It's displaced from the equilibrium and released from rest. That's going to be our amplitude is 0.02 meters. The kinetic energy is our question. So I'm just going to make sure we're feeling really good about these Ks. I'm going to make this one a dramatic lowercase and this a dramatic uppercase. And we're at where the X value, where it's just at 0.01 meters. Okay, so the total energy of the block is equal to the kinetic energy plus the potential energy. And E total is also equal to 1/2 Ka squared. And we're looking for the kinetic energy, so I'm going to leave that at K, and then U, and so the U, I'm going to do the spring potential, which is 1/2 Kx squared. I'm just going to solve for K. So K is equal to 1/2 Ka squared minus 1/2 Kx squared. And we're going to pull out the 1/2 K and have A squared minus X squared. And we have 1/2 multiplied by 100 multiplied by A, which is 0.02 squared minus 0.01 squared, and we get an answer of answer choice C. Okay, thanks for watching.